Question number 4 is a question on Boyle's law, and it says the setup of apparatus below was used in an investigation to verify an ideal gas law. A fixed mass of nitrogen gas was used in each investigation, and the results obtained are shown in the graph below. So over here we have a graph of the inverse of volume versus pressure. On the x-axis we have the pressure, and on the y-axis we have the inverse of the volume. Now question 4.1 says, for this investigation, write down the investigative question. In physical science, you're not allowed to write down a question that would give an answer of yes or no, or even just an answer that's a word, a one-worded answer. Whenever we are performing an investigation in physical science, we are looking for the relationship between two quantities. So we're going to say over here, what is the relationship between pressure and volume, or we can say the inverse of volume, for a fixed mass of gas at constant temperature? So again, we're interested in the relationship, and that is why all of our investigative questions start off by saying, what is the relationship? If the question is out of 2 marks, as in this case, then we're going to give 1 mark for the actual independent and dependent variable that's mentioned, the pressure and the inverse of volume, or the volume. That is going to get you 1 mark, and then 1 mark for the way in which you ask the question. What is the relationship between these values? If the question is out of 3 marks, then the 3rd mark will be awarded for mentioning your controls or constant variables. But in this case, the question is only out of 2 marks. Please don't forget that a question ends with a question mark. And that is your 2 marks for question 4.1.2. 4.1.1. Question 4.1.2 asks, what is the independent variable? So in the physics section, I reminded you that we have a stick and we have a big stone. The wind blows, and when the wind blows, the stick falls down onto the ground. Therefore, the independent variable is always plotted onto the x-axis, and the dependent variable, which is the stone that stands up, is going to be plotted on the y-axis. Therefore, the independent variable in this investigation is the pressure. The pressure that is measured in kilopascal, and for writing down pressure, you're going to obtain 1 mark. Question 4.1.3 says, write down 1 variable that was kept constant. So we know there are 2 variables. You can either say the mass of gas, or you can say the quantity of gas, or you can say the temperature. Either of these would get you 1 mark, and this question is only out of 1 mark. They could have asked for 2 variables that were kept constant, because there are in fact 2 variables that are kept constant in this investigation. Now question 4.2 says, use the graph to write down 4.2.1, the name of the ideal gas law which was being investigated, and state the law. The ideal gas law that is being investigated here is Boyle's law. For writing down Boyle's law, you're going to obtain 1 mark. Boyle's law states that the pressure of an enclosed mass or enclosed gas is inversely proportional to the volume it occupies at constant temperature. So pressure is inversely proportional to volume for a fixed mass of gas at constant temperature. And for writing this down, you're going to obtain your 2 other marks, giving you 3 marks for question 4.2.1. 4.2.2 says, the volume of the gas, we need to write down the volume of the gas in centimeters cubed when the pressure is 112 kilopascal. So we go to our graph and we need to find 112. So we see here is 100, here is 120. 100 and 120 is separated by 10 marks. That means that each little line represents 2, a value of 2. So this point over here is 102, This is 104, 106, 108, 110. We have 112 over here, 14, 16, 18, and 120. So again, going back to 12, we have 2, 4, 6, 8, 10, 12. This over here is where we're going to find 112 kilopascal. So now we can zoom out. Okay, make sure that you always measure your values accurately. We're going to go all the way up along this line. And moving all the way up along this line, we see that we cut through the graph at this point. So over here, let's use a thinner line instead. So we're going to cut through over there. From here, we're going to go all the way to the left. Unfortunately, it's somewhere in between, which makes it a little bit challenging for us to actually read off this value. Then we can zoom in again. We see we're counting in 0,1s over here. And between 0,4 and 0,5 is again 10 decimal places. So this is 0,41, 0,42, 43, 44, 45, 46, 47, 48. So we can give something between 0,47 or 0,48. If you would like to, let's write down an answer of 0,475, and that is going to be measured in centimeters cubed. So anything between 0,47 or 0,48, you can award yourself 1 mark for your answer in centimeters cubed. But please make sure that whenever they ask you to read off of the graph, you read off of the graph accurately. Now comes question 4.3, and this question says, under which temperature condition does nitrogen gas deviate from ideal gas behavior? Write down either high or low, then give an explanation. So the correct answer is low temperature, and we know this because we've learned it off by heart. But what is the reason? Well, when the temperature is low, number one, we're going to find that the average kinetic energy of the particles, and you're going to write out in full words, kinetic energy of the molecules is going to decrease. Therefore, the molecules are going to move slower past each other. Remember that these molecules, unlike ideal gas molecules, actually have attractive forces between them, and these attractive forces are going to pull the particles together. So we're going to say attractive forces become apparent. Don't just say intermolecular forces, specifically mention the attractive forces. Or in the case of pressure, if we're speaking about high pressure, we would speak of the repulsive forces. So don't be vague, be specific about the forces that become apparent. As a result of these attractive forces being apparent, what is going to happen is that we're going to find that the volume of the gas is going to be lower than expected. And the reason why it's going to be lower than expected is because this gas is actually going to liquefy. It's going to become a liquid. So you're going to get 1 mark for saying low. Then you're going to get 1 mark for mentioning either the average kinetic energy or the attractive forces. I'm not too sure how the marks were awarded in this question or in this question paper because the memo is not yet available. And then you're going to get 1 mark for saying that the volume is lower than expected or that it's going to liquefy. Okay, and this brings us to the end of question number 4. In the next problem, which is question number 5, we're going to look at energy changes in chemical reactions. That is those endothermic and exothermic reactions. So please be sure to join me there.